What is power density, W/Kj, for robot power sources? Imagine trying to run a robot that needs to move fast or lift heavy objects without carrying around a ton of weight. How do engineers make sure the robot gets enough energy quickly without becoming a burden? That's where power density comes into play. Power density, measured in watts per kilogram, tells us how much power a source can deliver relative to its weight. It's like asking, how much energy can this tiny battery give me in a split second? In robotics, this number is super important because robots often need quick bursts of energy to accelerate, lift, or operate sensors. Think about a robot arm grabbing a heavy box or a drone zipping through the air. It needs a power source that can give it a lot of energy fast. That's why power density is different from energy density, which measures how much total energy a source can store over time. Power density focuses on how fast that energy can be delivered when needed. Let's look at some common power sources. Lithium-ion batteries, which are used in many mobile robots, usually have power densities between 200 and 2,000 watts per kilogram. That means they can deliver a good amount of power quickly while still holding a decent amount of energy for longer runs. Supercapacitors, on the other hand, are champions of power density. They can produce thousands of watts per kilogram, making them perfect for short, intense power bursts like sudden acceleration or quick sensor data processing. But they don't store as much energy overall, so they're not used for long-term power. Other batteries like nickel metal hydride or lead-acid batteries tend to have lower power densities, often below 500 watts per kilogram. These are more suitable for robots that don't need rapid power spikes. Fuel cells and combustion engines can have high power densities too, but they are less common in small or medium-sized robots because they are heavier and more complex to run. In real-world robot applications, power density helps decide what kind of power source to use. For example, a robot that needs to move fast or lift heavy objects will benefit from a power source with high power density. Sometimes, engineers combine batteries with supercapacitors to get the best of both worlds, long-lasting energy and quick power boosts. This way, robots can perform tasks like rapid movement, heavy lifting, or quick sensor scans without being slowed down by weight or lack of power. To sum it up, power density for robot power sources usually ranges from a few hundred to several thousand watts per kilogram. Lithium-ion batteries strike a good balance, while supercapacitors excel at delivering quick bursts of energy. Picking the right source depends on what the robot needs to do, how long it needs to run, and how much weight it can carry. Understanding this helps engineers design robots that are both powerful and efficient, ready to handle a variety of tasks with ease.